Namaste. In the question, we see a cantilever beam AB whose end A is fixed and the free end B is connected to one end of a spring. The other end of the spring is connected to mass M. The length, flexural rigidity EI of the beam are given to us in the question. The stiffness of the spring is also given to us. The question further says that the fundamental time period of vibration of the system shown in the figure, neglecting the self weight of the beam, is nearly option A, 0.2 second, option B, 0.8 second, option C, 1.4 second, option D, 2.8 seconds. For solving the question, we are given the length of the beam L is equal to 2 meter, flexural rigidity of beam EI beam is equal to 5000 kilonewton meter square equal to 5000 into 10 raised to power 3 Newton meter square. Stiffness of the spring Ks is equal to 1000 Newton per meter. Mass attached to the spring M is equal to 50 kg. The fundamental time period T is equal to 2 pi upon omega n, where omega n is the natural circular frequency of the system, which is equal to under root k by m. So time period will be equal to 2 pi under root m by k. M is the mass of the system. Since the self weight of the beam is neglected, the mass of the system will be equal to the mass attached to the spring, 50 kg. K is the effective stiffness of the system. We can also call it equivalent stiffness of the system. When we look at the figure given in the question, we see that the beam and spring are connected in series. For series connection of springs, the equivalent stiffness can be calculated as 1 upon K is equal to 1 upon K beam plus 1 upon Ks. K beam is the stiffness of the beam. So, K will be equal to K beam into Ks divided by the sum of K beam and Ks. For a cantilever beam of length L, flexural rigidity EI, and subjected to mass M at the free end, the deflection at the free end will be delta equal to WL cube upon 3 EI, where W is the weight equal to mg. G is the acceleration due to gravity. Stiffness will be force per unit deflection equal to W by delta equal to 3 EI by L cube, or K beam will be equal to 3 EI beam upon L cube equal to 3 into 5000 into 10 raised to power 3 divided by 2 cube equal to 1875000 Newton per meter. Ks is already given to us in the question. So, the effective stiffness of the system K will be equal to 1875000 into 1000 divided by the sum of 1875000 and 1000, which gives us K equal to 994.467 Newton per meter. Putting the value of M and K in the expression for T, we get the time period T equal to 2 pi under root of 50 divided by 994.467 equal to 1.405, nearly equal to 1.4 seconds. This matches option C. Now here a small tip. When I was giving my competitive exams, I always used to get confused in the formula for T and the cyclic frequency F. So to remember the formula for T, you can remember it as T is equal to 2 pm. 2 pi for P and M for mass. This will help you in not getting confused with either it is T is equal to 2 pi under root M by K or 2 pi under root K by M or any other form. Thank you.